Welcome to Eduonix Learning Solutions for our course for GraphQL for beginners. GraphQL is a query language developed by Facebook. In this course, you will learn what is GraphQL, what are its features, why is it developed, and how to use GraphQL. We'll see its installation and connection. You will also learn what are the errors and types of errors in GraphQL and the ways to overcome these errors. GraphQL can be connected to external databases. It can also be connected to Python. It can also be connected to Ruby. We also have to learn how to make connection of a GraphQL to external interfaces. We also will create our own server. So by end of the course, student will be able to create its own server based on the GraphQL and SQL as the database. There is lot to learn in this course. Hope to see you inside the course. Welcome to the session for GraphQL. Now the question is, what is GraphQL? So GraphQL at a very basic level is a query language and it is developed by a very well-known social networking site, Facebook. It was developed as an alternative to RESTful endpoint. Now we'll come on to it, what is REST, what is API, we'll come on to it later on in the next session. It is an application layer query language, that is, client application databases are required. GraphQL is not a database query language, it is rather an application layer query language that you can use with any backend like SQL, MongoDB, Redis, etc. Let us see what are some features of GraphQL. So it is hierarchical in nature, means most application development involves creation and manipulation of view hierarchies. To achieve compliance with structure of these applications, a GraphQL query itself is hierarchical set of fields. The query is shaped like a data it returns. It defines a data shape. So GraphQL query mirror response. This easy to predict the shape of data returned from a query as well as to write a query if you know the data of your app or the data that your app needs. This makes using GraphQL very easy. It is a strongly typed, that means GraphQL ensures that query is syntactically correct and valid within the system before execution, and server assures about nature and shape of the response. It has client-specific queries. So this means the specification for queries are encoded in clients rather than servers. In majority of applications written without GraphQL, server determines the data that will be returned in various scripted endpoints, but GraphQL queries returns what client asks for and nothing more than that. It is introspective. So clients and tools have a power to query the type system using GraphQL syntax. This creates a powerful platform for tools and client software to build a top information like code generation in statically typed language, application framework or IDE or Relay. It also helps automatic parsing of data into strongly typed interfaces. It is version free. So shape of written data is usually client specific, so it is easy to generalize a server. When you are adding new features, additional fields can be added to server, but existing clients are unaffected. If features are removed, server fields can be removed, but still it works. So this removes the need for incrementing any version control. It is working with the application layer protocol. So GraphQL is the application layer protocol and does not require a transport layer. It is a string that is passed and interpreted by the server. It is also backward compatible. So backward compatible needs to be maintained in apps such as that does not require force update. Client specific query simplifies managing the backward compatibility. This is about GraphQL and features of GraphQL. Now in the next session we will see what is REST and what are its protocol, what are the disadvantages and why we are supposed to use GraphQL in spite of REST. Welcome to the session for knowing REST. Now as we saw, GraphQL was actually developed as an alternative to knowing REST. So it is fairly important to understand what REST is and what are its disadvantages. So let us see what is REST. So REST is the acronym for Representational State Transfer. It is used by browser as a language of internet. Rise of cloud computing had given rise to the use of REST as a choice for building API, that is application programming interface. RESTful API break down a transaction to create a series of small modules, each referring a particular underlying part of the transaction. Flexibility was available in REST for developers, but along with that there was a complexity to develop it from scratch. RESTful API was using HTTP methodologies such as put to change the state of or update the resource. Get was used to retrieve the resource. Post was used to create the resource and delete was used to remove it. Let us now see what were the disadvantages of REST. So technical weakness in REST. It had the requirement of multiple round trips. Now usually when it were app that came into the existence, so fetching complicated object graphs require multiple round trips between clients and servers for even single view. For mobile apps, it was undesirable because of the variable network conditions. It was not flexible to use REST because updating a system was a problem when there was change by adding data and files in REST endpoints. Old clients used to receive additional data because data fetching specification was on the server rather than with the client. It resulted into payload growth over a time for all clients. Versioning was the solution, but it increases the server complexity. Now, it also lacks metadata, so REST endpoints are loosely typed and lack machine readable metadata. It was not built for within organization communication, so it is developed for long-lived network-based applications that span multiple organizations. There were other drawbacks too. So let us see what were the other flaws with respect to REST. Now, if we look at other flaws of REST, we can see there is no actual understanding of what REST API is. So cause no one understands what method means. So for example, if we look at the list over here, there are different codes. 200 indicates OK, 201 says created, 202 indicates accepted, 203 says non-authoritative information, 204 says no content, 205 says reset content. So there is no proper understanding to the language. Now for example, 200 is okay for REST code, but it means what? Whether record is updated or should it return 205 updated? And also along with that, if we see 303, it says see other. The things like this or codes like this are also unexplainable. So that means also vocabulary is not fully supported because put and delete is not also understood by most of the browsers. So different browsers understand codes differently. For example, 303 is received, one browser may ignore it and other may cancel it. REST vocabulary is not rich for API, so it is not suitable for a wide variety of applications. We have three vocabularies to deal with. One is with numbers, that is 201, 202, etc. Then there is a HTTP request, that is GET, POST, etc. And along with that, payload is also available in JSON. So complexity is high and it leads to the error. Here, debugging is also a very complicated job. So it's hard to debug because we need to look different locations to understand what actually is happening up. RESTful application programming interface is mostly tied to HTTP. So it is dependent on the channel of transmission. It is dependent on HTTP protocol. Moving from HTTP requires restructuring of everything. So information from different locations we need to check to make it meaningful. So these are the reasons the REST was not used and rather the GraphQL is put to the use. Next we will see what are the reasons we have to use the GraphQL. So far we saw what is GraphQL, what are the features of GraphQL. We also saw what is REST, what are its disadvantages. Now finally let us see why to use GraphQL. So here are 7 reasons to use GraphQL. So only the content that is needed by the website is fetched. Since it is strongly typed and query structured, only content required is fetched. All contents for a single web page can be fetched in one request. That means there are no multiple round trips. Third is less coordination needed between API and websites since query defines what is required. So there is no much coordination required between application programming interface and website parties. GraphQL has got schema, so which defines structure. That means the structure is available to fetch your data. That creates less complexity. Versioning is not an issue since queries are client specified, so only the data that is required is sent. Therefore, there is no need of versioning and even the update of the app doesn't affect much. Smart client-side caching is available and it is efficient to make changes because it doesn't send any unrequired data to the clients, which was happening with REST architecture, increasing the payload of the client. So these are the reasons the GraphQL is developed and is used over the REST API. So let us learn about the details of GraphQL, programming the GraphQL and using the GraphQL in next session. Welcome to the session for installing GraphQL. Now before we start installing actually the GraphQL, our first job is to install Node and ES6. So let's start installing Node version 6 from the official website. So you have to get onto the official website of Node v6 and you have to click on Windows installer. So if you see installer has started. Now I already have got it installed on my machine, so I'm not going to install it again. So rather I'll move with installing ES6 because we may require a feature such as promises class and fat arrow functions later on. So we can install ES6 for the purpose. So now if you have got installed ES6, you can say npm init and then wait for the system to respond to it. Now you have to say npm install GraphQL, save, and now it will automatically start installation of a GraphQL as you can see over here. it has started with the installation. So by the time it finish up the installation, let's create a server file so that we understand GraphQL is working in collaboration. So let's start writing the code in Notepad. So we got to say where GraphQL build schema, and you have to say what is required. So require is GraphQL, and then close this. Now next is variable, that is schema, equal to build schema, and then it says type query and query is of the form string, and then you got to close this. Now next we declare variable root, which is equal to hello, and then you have to say whenever this sort of query comes, the value that is to be returned is, so return first of all as a function we'll specify, it should be hello world, and then close it. And now we have to say GraphQL schema hello comma root, and then something has to be returned to the console log. So let us write console.log, and in the bracket write response, and close it. So now save this, and we got to do some procedure or some step in command prompt to make it run. Okay, while saving it, we have to save it with a name, that is server.js, and since I have the same file stored, so now coming back to the command prompt, we have to write node. Okay, now first of all we have to change the location to, now I have kept it on my desktop, so I'll change the location to desktop. So it says and now we have to make it a node, so we say node server.js. Now there is some error into it, so it says type query has got some error. So now once you make the correction, you will be able to see a response has come as a hello world. So now this we ran independently. Now we will use one of the most famous HTTP extension or HTTP framework, Express, And we also see newly created interface GraphQL, in which it is very convenient to write your queries and text, and which works in collaboration with Express. So we will try to install it and then run it in the browser. So let's see how to do it. Now let's take a location back to users Eduonix, so that I can install. So you can choose your location. So here we are supposed to write npm install express GraphQL and save. So now once I hit enter, again installation will begin, but this time Express with the GraphQL. So by the time the installation finish, like we did it earlier in a notepad, we are supposed to write a code. So let's get back to the notepad and change the code that we have written. So here the code is a bit simple, not much complicated. So where Express require Express, and then where GraphQL HTTP. So we now have to prompt Express GraphQL, and we have to build schema. So we have declared that later on. So but schema has to be taken from a GraphQL. So now see where schema, build schema, type query hello, again this is same string. Now where root is required here, so the root provides a resolver function for each API endpoints, where root hello and return should be hello world, because hello will be the query and the value should be returned as hello world. And then variable app, which is equal to express, and app.use we have defined, we are using GraphQL and GraphQL HTTP. Schema has to be pulled from schema. Root value has to be taken from the variable root that we have declared. And we are going to use a new interface, GraphQL. The name of the interface is GraphQL. So we have set the value to the true. And now we require a location where browser should listen to it, a port basically. So we have kept it on a port number 4000 for the time being. So save this file and come back to the command prompt, and like we did earlier, we have to change the location to desktop, because this file is on the desktop. For you, you can keep it anywhere. And now you can say node server.js, and it will reply that it is running on a local host 4000. So go on your browser and open this location. So copy here and open it in your browser. In the browser, you will be able to see GraphQL at the top, a play button besides its prettify and history. These are the two things, and there are two sections to it, the left side and the right side. Now at the left side, we have to write a query for which we'll get a response on the right side. So open up the curly braces, press Ctrl space bar. So we have only one query over here, which is hello. And as I told you, whenever you'll pass a value hello, something should come in the response. We have described the return value, isn't it? So once you will run this, so you will be able to see a hello world is been returned. So this is how you run on your browser. This is how you run GraphQL on your browser. But for our examples, we can use the external databases or already available API. So let's see where we can look for this API. You can directly Google SOAP GraphQL API. So SWAPI GraphQL API, and you will be directly taken on to the link where you can directly write the queries, and you can practice whatever queries that have been taken in this course. Welcome to the session for using GraphQL plus Express. up till now, we saw how to use GraphQL, installing Node v6 and then installing the GraphQL and then looking out the response of hello world. Now we will use GraphQL along with the Express. So this is the simplest way to run in GraphQL API server with an Express, which is a popular web application framework for Node.js. You will need to install two dependencies. Now let us come on to the command prompt and then see how to install Express and the dependencies. Now let us type npm install Express and then we'll say Express GraphQL and then we have to save it. And now we see installation has begun. Now how we'll be assured whether it is working or not? So we'll modify the hello world previously written by us to make certain changes into it, and then we'll see a new interface of GraphQL that will be running in the browser to write the queries and check for the responses. So let's come on to the notepad. So we are using the Express module to run a web server, and instead of executing a query directly with the GraphQL function, we are using Express GraphQL library to mount a GraphQL API server on the GraphQL HTTP endpoint. So let's begin. So let's say where Express equal to, we need Express, so we say require, and in the bracket what is required is Express and then close it using the semicolon. Then we also need one more variable which is GraphQL HTTP, which should be equated to, again we require something. So what is required is, in the bracket, it's Express GraphQL, then close it. Now we also require a schema. So, but that will be available from a code itself. So presently writing it in a curly brackets. And then what we require for the schema is GraphQL. So we see later on with the flow. Now let's say where schema equal to build schema. As I told you, this will be available from the code itself. And then in the bracket we need a type. So type is query and we need hello and the type is string. So we have to understand here we are building a schema and then close it. Now we say where root, it's a new variable root, and again we say hello. So what response are we expecting? So we expecting a return. So we say return function. So what we read in a return is hello world. This is the response we are expecting once we are running this code. Close with the curly brackets, then semicolon. Now use where app. So this is another variable which we say express. Now we are using this express function because it creates an express application. The express function is a top level function exported by the express module. So we have to use it and then say app.use. Now you may wonder what app.use does. So it mounts the specified middleware function or functions at the specified path. The middleware function is executed when the base of the requested path matches the path. So let us see. So app.use is being used, and then in the bracket we have to specify the path. So it says GraphQL, okay, and comma, it is GraphQL HTTP, and then how it should be. So it has to take the response has to take schema from schema that we have made, okay, and then it should have some root value. So root value should be taken from root, and then since at the beginning I told you we'll be using a new interface GraphQL which has to be accessible from the browser, so we are making it to the true so that we are able to access it, and then close all the brackets. So inner one is a curly bracket, so we are closing it, and two round brackets. Now we are supposed to assign a port from where a response should come, so we say app.listen. Let's keep the port number to 4000, and this, so what basically app.listen does is it binds and listens for connection on the specified host and port, and now we will call console.log, and we want to reflect something onto the log. So what you wish to do, you can write in here, say for example running a GraphQL at http, or you may write local host 4000 / GraphQL, and then close it, and semicolon, we must not forget this. So this is, again we have to save as server.js, so save as server.js. Okay, now I already have this file saved on my system, so I'll not be saving it again, but you do save it, and then we'll see what you have to do. Coming back to a command prompt and pointing out to the same location desktop, we again have to run node server.js, and now we have to get back to the browser since this interface works with the browser, and now we see it is showing running a GraphQL at the local host 4000 / GraphQL. Going back to the browser, in the browser we just have to type the address, so it's localhost http localhost 4000 GraphQL, and then hit the enter, and now we are able to see a new interface called GraphQL is available for us to write the queries. And so as now we have to see hello world, so we have to put a query in here, so we say hello and then play it. Now we are able to see a response is available to us as the hello world. So this is how we can use browser and the extension GraphQL to put the queries and check the response. Check for the response at the right hand side. So this is about using the interface GraphQL in your browser. In the next session we will see how to develop the schema and what are the different types. Welcome to the session for programming in GraphQL. So we saw how to install and use GraphQL. This is the pretty interface that we have seen. Now how to do the programming and how to raise the query, that all we have to see in this session. So now let's begin with just a very pretty small query and see how GraphQL responds. So GraphQL is about asking for specific fields on objects. Let's start by looking at a very simple query and the result we get when we run the query. So let's see, and as we know, the query is always the reflect of what it is being asked. So for example, let's put a query for all starships, and to run the query you can either click Ctrl Enter, or there is a run symbol at the top besides the name, and as we see at the right hand side we are able to get what we had asked for, and the query was also auto-filled with the available fields under the all starships. So if we match what we had inquired and what has been received, we see a structure is pretty same. So edges, a node and ID have been returned. So in GraphQL, usually what we ask for and what we get is of the same shape. So you always get back what you expect and the server knows exactly what fields and the client is asking for. Now let's put another query in the field. So for example, we say if we press Control space bar, we'll get the list of all the available data and all the available fields that we can put a query on. So let us say in film, in bracket, we have to mention the film ID. So for example, let's take 15, and then inside film, what do we expect GraphQL to return us? Again, if you press Control space bar, it gives you the fields that can be returned. So for example, I have now queried for title. So now title is what I expect in return. And now let us see whether it returns what I have asked for. Now we'll end up in the error for reason being there was no entry with the film ID of 15. So let's query it with the film ID 2 and see what it responds. So now if we see a response has come as we had asked for. So film and under that the title name which has got film ID 2 and the episode ID is been returned. So we can also ask for multiple fields inside the one particular field. The query in here are interactive. So for example, you can include and keep adding the fields as you want. So for example, if I say person and if I provide a person ID, so whatever you provide it, say for example 1 for now, and then in the bracket, if you press Control space bar, you would know that there are the fields that can be included. So for example, I can include name, I can include birth year, I can include eye color, and so on. So you can keep adding, and then if you run the query, you get what you ask for. Now if you observe the structure, the same is what we had asked for. So this is how you can keep changing the query and keep adding the fields that you wish to add. So pressing the Control space bar, for example, I now can include height also, and then see a height has been included. If you wish to add much more details, so for example, if I wish to add a skin color, I can add a skin color too. So this is the way we can change the query and make certain changes in spite of multiple rounds. In a one way, we can keep including what we wish to ask for. We have the ability here to pass the arguments. Now in GraphQL, every field and nested object can get its own set of arguments. So making GraphQL a complete replacement of multiple API fetches. You can even pass arguments into scalar fields to implement data transformations once on the server instead of every client separately. So for example, if we see here, say for example, Starship, and we provide a specific Starship ID, say, or you may take another example of say films, and now we provide a film ID, and the ID can be 1. Say for example, now it has got its own set of arguments as we saw earlier too. So what we require, we can check providing control space, we can see, so there are arguments to the arguments which help us fetching the data in a one go rather than again and again having a round trips to the server. So, which is the advantage over other API. So as all we see, without a multiple round trips, in a one go, a detail of whatever we require and in a structure what we expect is being returned. So if you can see over here, the species connection had got its own set of data or own set of fields which were auto-filled and are also reflected in the result. So species connection had got edge node and ID which was auto-filled when I raised the query and is included into the result on the right hand side. Now if you have noticed, the result object field match the name of the field in the query but don't include arguments. So you can't directly query for the same field with different arguments. That's where you need aliases. Then let you rename the result of a field or anything that you want. So let us see how we can use aliases. Let us see how we can put a name onto the query. Say for example, person name and put a colon and then write a query in a usual way. Say for example person and in the bracket we are supposed to include the person ID and in the curly brackets we are supposed to include what we want. We are expecting name and we expect birth year and we expect eye color. And now if we see, we are getting the error because we forgot to provide the person ID. So once you provide the person ID, we are able to see an aliases has appeared. So person name and then the argument have been returned with the values they are holding. So you can change. So it's up to you. You can put it 11. So person ID with 11. You can also change the name. Say for example, it can be human. So now an aliases has been changed to human. So this is how you can name the query. This is where you require the aliases. Now coming on to the next part, which is called as fragments. Now, for example, suppose we have a relatively complicated page in our application, which let us look at two people or two things side by side along with their other credentials. For example, you can imagine that such a query could quickly get complicated because we would need to repeat the field at least twice and one for each side of the comparison. That's why GraphQL includes a reusable units called fragments. Now fragments let you construct a set of fields and then include them in queries where you need to. Here is an example of how you can solve the above situation using fragments. So now for example, if you see in here, now I have raised two comparisons. So one is left comparison and the quantity or the object which I am trying to compare is species, and then I have to specify a species ID also. So I have kept it as the ID1 and I have a parameter that needs to be compared. So because a parameter is necessary, so I have mentioned it as the average height. So now the average height has to be compared and there are certain more credentials that needs to be compared. So I have raised as a left comparison and right comparison and then I have made these two fragments and now these two fragments have got a common parameter, for example average height, and I have to perform this fragmentation on species. And when the fragmentation is being performed, what all credentials or what all parameters or what all fields, if I say in the language of GraphQL, I wish to see, that I specify in here. So for example, name, classification and average height. So if we see over here, query that has been answered and is returned as, so in the left comparison, the name human, classification mammal and average height is 180, and there is a right comparison where it is name Wookie, classification mammal and average height is 210. So the concept of fragment is frequently used to split the complicated application data requirement into smaller chunks, especially when you need to combine lots of user interface components with different fragments into initial data fetch. So this saves the round trip to the server and rather brings the compared data or multiple data in one round trip. This is again a bit dynamic also, as for example, you can keep changing the data and the query and see there is an immediate response to it. And for example, if I say or try to compare 3 and 4, and then now we see the value returned is bit changed. So it is dynamic as well and faster process. Now we have been writing all of our arguments inside the query string, but in most applications the arguments to fields will be dynamic. So it is not a good idea to pass these dynamic arguments directly into a query string, because then our client-side code would need to dynamically manipulate the query string at the runtime and serialize it into the GraphQL specific format. Instead, GraphQL has first-class way to factor dynamic values out of the query and pass them to the separate dictionary. These are called as variables. Now, there are three things that are required in the variable. So first we'll type a code and then see what are these three things that in fact help us as a variable. So now write query and write any name to the query. Say for example, I say my query, and then start writing a code or put a query. So for example, I say film, and in the bracket I have to say film ID, but now I intend to dynamically include the film ID, so I'll assign a variable to it. But you can give any name to the variable. For example, we can write over here $film ID. Now I have not declared this that I am going to include my variable in the code, so we have to include this where you are declaring the query name. So for example, you have to say $film ID, and the quantity that it is going to take is ID. And let us now, so what you want query to return. So when it receives a film ID, so I want it to return, say for example, title of the movie and episode name or episode ID for that case. Now question is, then where will we pass the value that will be captured by the code and the result will be displayed? So that we have to mention it in the query variables. So we will say, what is it? It's film ID, and the value that I want is, say for example 2. If you want to pass 2, you can pass 2. If you want 3, you can pass 3. And the value is being returned as title, The Empire Strikes Back, and episode ID is 5. So in a similar manner, if you wish, you can pass any other value, say 3, and then C. So the value returned is return of JD, and episode ID is 6. So you can include other variables if you wish to. Say for example, the director name you can include, and then hit the query. So it says Richard, and again you can include any other, say for example, producer's name, and then the value returned is Howard, George, and Rick. So this is the way we can make it more dynamic. We can put variables into it and then pass the value, which value will be captured by the code itself and will be returning the value based on the values that you pass. Now, it's not necessary that we keep passing the value. the default value can also be assigned to the variable. But then one thing we have to notice, whenever if you pass a value, even if there is a default value that is present, the newly passed value will override the default value. So for example, if I see here, I just have to say equal to, and the value that I can give is 1, say for example, and this query variable have to be removed for the time being. So the value returned is episode 4 and title is A New Hope. So in this way we can keep the default values if we wish to. And now even if there is a default value, but still I wish to pass a value to it, so I can say for example 2, quite easy one. And then if you see, the one value is being overwritten by 2. So if variables are passed as a part of the variable dictionary, they will override the defaults. Now, so far we saw how we can pass the value via variable. Now passing a variables in arguments solves a pretty big class of these problems, but we might also need a way to dynamically change the structure and shape of our queries using variables. For example, we can imagine a user interface component that has summarized and a detailed view where one includes more fields than other. So let us look at the problem here. So we can use the alternative, that is directive, to make a program bit dynamic and user specific. So it changes with the change in the received values. So for example, we can say we name a query as query, and then say for example we name it as space, and in the bracket, like we define the variables, we'll define once again here. So for example, we took episode, so let's take episode. So and the value it was holding was ID, so still the same value, and then we might some other name to some other variable that we'll be using. Now say for example we take it as, so change, pretty understandable, yeah, and then we say now this requires a value to be true or false. So whether we want it to be changed, we pass a value true. If we don't want any change, so we pass a value false. So the type that it holds is Boolean, and we give, okay. So now let's start writing a query. So say for example we have a film, and then we need a film ID for it. So let's film ID, and it will take the values very obviously from the episode. Say it was just a generic name, you could have given any name, but for our reference we're taking it as it is. And then what you want once a value is being passed, so what do you expect? So I expect say title out of it, and there is one more, say value that I'll take, say vehicle connection. So that vehicle connection should only be included when, so say if we will use if change is being set to true. So if change is received, then only do it. Now vehicle connection has got some of its own subfields. Now what do I expect when, for example, a change value is being passed to true? So what will you expect? So I may expect a total count, or say I may expect a page info, or I may expect vehicles, say for example. And if you find some error, you can go and check. So what it says vehicle must have selection of subfields. So now vehicle may be also having some subfields into it, so you can select them too. So if you want to, say it can have a name, so it can have a class. So likewise, so let's keep it to total counts only. So once a value is being passed as true for the change, so now again the case is same. So what we are supposed to do is to run this query. We are supposed to pass a value for episode, which say you will keep to 1 for our example for the time being, and the other value that you want is change, and you can keep it to false for the time being. So what it says, and then close the file and then run it. So now since we have passed the value of a change as false, we observe here that only title has come, and there is nothing that has come from vehicle connection or total count. Now we can try to change to true. So as we are expecting a change, so and then close the statement and run it. So now we see along with the title, a vehicle connection has come, raising the total count to 8. So in this way we can modify the code and make it bit dynamic depending upon the client requirement or depending upon the client side code. And so a directive can be attached to a field or fragment inclusion and can affect execution of the query in a way the server desires. The core GraphQL specification include exactly 2 directives which must be supported by specific compliant GraphQL server implementation. So one was include, under which we write if, and there is another way which can say @skip. So skip the field if argument is true. So this is also one way of doing it. So directives can be useful to get out of the situation where you otherwise would need to do string manipulation to add and remove the fields in your query. Server implementations may also add experimental features by defining completely new directives. So this is also a way of making your code bit dynamic. So directives usually help us making our code bit dynamic. And in the next part, we will head on with the mutations. So let's begin up with mutations.